Support comes from St. Louis Public Library Foundation, helping the library serve children and their families with programs and services needed to become lifelong readers. More information about the foundation is at slpl.org.
This is St. Louis on the Air from St. Louis Public Radio. I'm Elaine Cha. Copperheads are the most common venomous snake species in Missouri, but scientists know surprisingly little about them. How many are there? Where do they move? How do they find mates? Where do they hibernate? These questions are at the heart of Ben Jellin's work. Ben is an associate professor of biology at University of Health Sciences and Pharmacy in St. Louis, and he joins us now to talk about what his research has found about these snakes, creatures that live all over Missouri, including near heavily populated and urbanized areas like St. Louis. Ben, welcome to St. Louis on the Air.
Welcome. Thanks for having me.
Sure. Now, this study, what initiated it and what makes it important?
The main thing that initiated this particular project was it took place at Powder Valley, which is right in suburbia, Kirkwood, and they receive 80,000 visitors annually that hike the trails. Some people, the trails are paved, so some people are out there in flip-flops, and there's also a population of venomous snakes. So the whole idea was to gather as much information about them as possible to try to figure out how everybody, humans and snakes and everybody else, could get along the best without any incidents.
So safety was one of the reasons?
Always, yes.
Now, how is it that snakes avoid the threat of humans?
Well, they don't really. Year after year, there's further encroachment in their habitat, but copperheads, particularly being a pit viper, they're ambush predators, so they're sit and wait, but they are very, very, very secretive, and they're very camouflaged. Okay. And I don't know what, I hear all sorts of different things of people's opinions, but snakes are not aggressive. And in fact, I've been doing this for 20 some odd years with a number of different species, and particularly the venomous snakes, they always rely on their camouflage.
Okay.
And I can't tell you how many times that we've had a radio transmitter in a snake and we're trying to locate it, and we are within a 2-foot area. Like, I know the snake is within 2 feet of me and I still can't see it, but it also gives absolutely no indication that it's there because they are food for so many things. People also think that they're kind of on top of the food web, but they were food for owls and hawks and coyotes. The babies are food for moles that burrow up underneath them.
Okay.
So their best bet is camouflage and not defense.
So what does a copperhead look like then?
Well, hopefully we'll have some pictures, right, for the web to go along with it. But the name says a lot. So the head is very copper colored, and then it has bands, kind of like hourglass-shaped bands, and they live in oak hickory forests. So as the colors are very similar to brown dried leaves, which is great for blending into the or for the fallen canopy, for the leaves on the ground. What's bad is that other snakes have this pattern too, and a lot of times one of the very most common snakes in the whole eastern United States is a northern water snake, and they're very commonly mistaken for copperheads and killed just because they look like something venomous.
We're going to get back to water snakes in just a little bit. So you were describing the radio transmitters. How is that part of the research? What role does that play?
So if you want to learn really anything of value about an organism, you need to find it and hopefully find it again and again and again. The more times you find it, the more information you can gather, particularly if you're interested in something about movement or temperature. You want to see where they are in April and May and June and July. And for a snake or for anything as secretive and camouflaged as a copperhead, you kind of have to level the playing field. So radio transmitters were implanted in the snake's body cavity by the St. Louis Zoo, who's been a wonderful partner for 24 years. Next year we celebrate 25 years of working together in collaborations. So the copperheads were found in the field, implanted at the St. Louis Zoo with the radio transmitters, got a unique frequency, and then they're released exactly where they were captured. And then we follow them daily, 7 days a week, all through the entire activity season, which is early April through right about now. With a couple cold days, I bet they're heading straight back to where they're going to hibernate again.
How do you catch them?
Safely.
We certainly hope so.
So yeah, there's a number of different things that we use, but ultimately we use clear plastic tubes of different diameters, and the idea is the diameter of the tube is long enough for this or wide enough for the snake's head to get in, but once it's in, not wide enough for the snake to turn around. So the tube is pretty long, so I hold one end way far away, and you kind of gently coerce the snake into crawling into the tube. Then as long as you hold the tube and the snake at the same time, the worst thing you're going to do is get pooped on, which isn't really fun, but it's not going to ruin your day.
Right,
like
and it's not going to be poisoned.
Right.
It sounds a little bit like a finger trap in a way.
Yeah, honestly it is, yeah.
So what is it that you have found about copperheads that maybe wasn't as well understood before this study began?
I think we found out quite a few things. One, they're definitely not as populous as what we thought they were going to be. I think their numbers are dwindling. But again, there's, as you were mentioning at the onset, there's really not a lot of current data about what the population size is. So if you have no benchmark, you don't know if it's increasing or decreasing. And there's certainly, like I was saying, mid-food web, which I did not expect at all. I didn't expect them to be prey for so many other animals that were out there. But one of the surprising things is their personality. Every individual snake had its own personality, and they would hang out at certain areas at certain times, but they would always know exactly where they are, where they were going, and what day of the year it was. And they would always return to the exact same location to hibernate. And snakes can't migrate. They don't have wings. They can't fly south for the winter. So they have to get below ground, below the warmer than freezing in order to survive the winter. So finding which hole is absolutely essential. So when they do, and they find that hole, they return to it year after year after year. We had multiple snakes do it 3 years in a row, which they probably would have done it longer, but then they fell victim to prey or they were run over in a couple instances.
Right. Is there any role that things like streams or other like man-made kinds of things will interrupt that path back to the hibernation?
That's an interesting point, and we really started seeing some of that at Powder Valley. So it's pretty unique. Again, in suburbia Kirkwood, you've got suburbia off to the north and the east, and you've got interstates off with 44 and 270 off to the south and the west. So they're really isolated. But within Powder Valley, so it's a wonderful little patch of habitat for them and migrating birds and other species that are around. But within there, you have a concrete driveway bisecting the park, and you've got edges, distinct edges around the boundary of the park, and there's a couple dry creeks, and there's power line corridors. And we found that the snakes would use the power line corridors for movement. They would treat it as edge habitat. And that's really important for the species because they'll hibernate in these rocky outcrops, but they kind of need open grassy areas for an abundance of rodents for their main prey. So that was really interesting. But we found they avoided roads at all costs, and they avoided streams at all costs in terms of what their movement paths were.
Yeah. What is the life expectancy of copperheads in the wild? And are they kept at zoos?
So even Powder Valley itself has a wonderful interpretive center. And if anybody hasn't been there, go check it out and take your kids. It's the most wonderful place. They will love it. But within there, they also have a timber rattlesnake that's live and a copperhead that's live. They do well in captivity. They could probably live for 30 years. They don't live nearly that long in the wild. And I've done radiotelemetry studies with copperheads and water snakes and also Massasauga rattlesnakes. And the longest we ever had any snake consecutively was maybe 7 years. But most of the snakes, the copperheads particularly, we were lucky if they made it through an entire year before they were eaten or something happened to them. So I would say in the wild, they reach adulthood maybe between 2 to 3 years. And if they live another 2 to 3 years after that, they're pretty fortunate.
Right. We're speaking with Ben Jelen, who is an associate professor of biology at University of Health Sciences and Pharmacy in St. Louis, and we're discussing copperhead snakes, which are the most common venomous snake in Missouri. So this brings me to the question about where you are and what you do. So you are at the University of Health Sciences and Pharmacy, which was the St. Louis College of Pharmacy.
Still is. The undergrad program got a new name. The professional program for the College of Pharmacy and everything in St. Louis, the oldest west of the Mississippi.
Yeah.
We're still here. We're still very vibrant, oldest pharmacy school west of the Mississippi. But we added a bunch of new programs in the undergraduate side of things.
But the work that you've been doing for many years, and you are at a school that focuses on health sciences. What is the connection between copperhead snakes and the institution that you work in?
Well, research is research. And if you can provide any type of research experience for undergraduates, it's an amazing experience. It's help on your project, but also it fits in the grander scheme of things. If I teach in the undergraduate program, which I do, I teach intro biology where we'll discuss evolution, we'll discuss mating strategies, reproductive ecology. Some of my work is on pheromones, which is a basis of the endocrine system, so it clearly links in. And of course, with venomous snakes too, there's all types of medicine that can be made and derived from their venoms, particularly anything involving targeted tissue death, which you would think cancer, right, to target a specific area and stop those cells from their ongoing reproduction.
Right. So in the final word about copperheads, why is it that people should be spending time, thinking about copperhead snakes, apart from, the possible venomous bite?
Yeah, in all honesty, I think copperheads would enjoy if people did not think about them at all.
Okay.
And just left them alone to go about their business. But of course, there is the venomous snakebite part, which always draws people in. But way more than that, I think it's wonderful that we live, St. Louis, very wonderful city, very big, but there's little taste of wild. You can go within suburbia Kirkwood, still within the county limits in suburbia St. Louis, and you can hike amongst venomous snakes. The odds of you seeing them are infinitesimally small, but it adds a little bit of mystique. It's like the possibility of seeing Bigfoot out there.
And just to make sure, and the venomous bite of the copperhead snake is not fatal, right?
Correct. People can be allergic to everything, but you are more likely to die by being struck by lightning than you are with a venomous snake bite. You're more likely to die being crushed by a vending machine than you are a venomous snake bite. So you really have to work to get bit. So if you see one, best thing to do, it is more scared of you. It's not cliche. It's real. They're more scared of you than you are than you are of them. Just take a wide berth, walk around them. Everybody will be fine. Venomous snake bites happen to a person's hands or fingers mostly. That means they're way too close, picking it up, trying to do something that they're not. There is the occasional snake bite on the leg. So if you are hiking out in the wild in an area where there's venomous snakes and there's a log in front of you, step on the log and then well over the other side. Don't just step right on the other side of the log. You may step on something that's trying to hide.
Okay. So we just need to act right, basically, is what, what it comes down to.
Just be polite. Just be polite citizens, and that's all.
So in the last couple minutes, there is another long-term project that you're doing, and you mentioned water snakes and pheromones. What's notable about what you're doing there?
So with pheromones, this has been a very long-term project. This one started in 2007-ish, and there's been multiple parts and multiple corners that we've turned on it. But I was always interested in how boy snakes find girl snakes. Okay. And it's a lot more complicated probably than what we learned in school, which was the females the males battle or fight, and then the winner of those competitions mates with the female. So in that regard, male behaviors were really under strong selection, and female behaviors weren't. But if you think about energy investment, all the way from the beginning of the egg to rearing, growing the offspring and everything that's involved with it, it's like, no, there's no way they should be passive participants. So I started really focusing on the female aspect of reproductive ecology, and they have so much more going on than people ever gave them credit for, because nobody really ever looked at it on a fine scale. Right. But the ultimate goal was to determine what the pheromone is, how the male snakes are finding the girl snakes. Not that we're interested in it in water snakes per se, except for the pursuit of knowledge and all those wonderful things. But applied, what you could use it for invasive species. Like there's Burmese pythons in the Everglades. There's brown tree snakes in Guam. There's black and white tegus, which is a lizard species in Southeast. And people are trying to eradicate them because they're eating crops, they're destroying wildlife, they're non-native, they're invasive. So if you could find a way to easily lure them in, you could help eradicate them from the ecosystem. So that's kind of the ultimate goal, is to use those powers for good, if you will.
Ben Jelen, thank you for joining us today. Ben Jelen is an associate professor of biology at University of Health Sciences and Pharmacy in St. Louis.
This episode was produced by Emily Woodbury.
Audio engineering and podcast design by Aaron Dorr.
Our executive producer is Alex Hoyer.
St. Louis on the Air is a production of St. Louis Public Radio. Understanding starts here.
Do you find yourself regularly listening to episodes of St. Louis on the Air? Suggest us to a friend you think might enjoy our conversations. And leave us a review and rating on Apple Podcasts on the App Store. It's the simplest way to help people discover our show. Thanks.
St. Louis Public Radio is a member-supported service of the University of Missouri St. Louis.
The Gateway brings you the day's news each weekday from around the St. Louis region and the state capitals in Jefferson City.
Our schools are accredited. We don't need this bill.
And Springfield.
How many more years must pass before lawmakers see time is of the essence?
I'm Abby Larico. Join me each weekday for The Gateway on the STLPR app or wherever you get podcasts.